Hey, hello, curious minds. Welcome back, data champions, to Decode Dataverse Journey with Tina. If you're someone who wants to build a career in data, maybe as a data analyst, a data engineer, or BI developer, then you are in the right place. So, this is a series. We are starting from a very foundation of SQL, and today we'll be talking about a database, what is it actually, and how it became the heart of every modern application. So let's just start with a simple thought of using apps like Instagram, Amazon, banking. For every click you made, every post you like, and every order you place is data. And where all the data goes? How is it stay safe, searchable, and structured? That's where our topic comes in, is database. Before database existed, way when the computers invented in 1920s by Charles Babbage, to communicate with the computers we just use ones and zeros as input. So later, long way in 1960s, we got introduced to a C language which became very popular and which is complex but became popular. So what does the language does? The advantage of the language is process the data. So when we wanted to communicate with a computer, a person needs to give the computer a language so that the computer will be understandable. So earlier we used ones and zeros as input. After C was invented, we use C language to communicate with the computer. And what is the disadvantage of the language? So it cannot store the data. For example, let's take an application when C language was invented, and later on C++ was invented in 1970s. And when they developed an application of railway ticket booking application which takes in the data, but where does all this data stores? In a flat file, notepad, or text file. So let's say, for example, I wanted to book a ticket. So the number of the ticket is entered in a flat file, and the name, age, from, to, date, and the price of the ticket. So it stores the data in this way. If we wanted to store many data while printing every ticket of all the passengers, so they used to type manually into this flat file. So it becomes very hectic to handle thousands and thousands of everyday data. So what would go wrong? Someone can easily delete or overwrite someone else's records, or for suppose if the person is going from Hyderabad to Delhi, can be changed easily as Chennai to Delhi. If the person loses his ticket, then he wanted to go back to the manager and ask for the ticket, then this will be easily overwritten by someone. So searching for a person would also take forever from this flat file, and there is security zero. Anyone could open and change the file, and as the file goes longer, the system would just slow down. So these are the issues of saving data on flat file, text file, or notepad. So first issue is size issue, second is security, retrieving of data is slow, and the language used to retrieve is C language, which is very complex, and there will be no indices for processing so slow. For example, if I wanted to, for suppose if I gave a book to a person to keep it safe and give me tomorrow, then the one person has stored somewhere else in eighth room in some kind of cell, let's say 30th shelf. Then this person is absent the next day. So when I wanted to get this book from safe, I need to check every room. There are suppose 15 rooms with 50 shelves each. So I need to search for every room. If this person is absent, I need to do this. So no indices and slow processing for this, and concurrency issues. For example of a concurrency, if I wanted to book a ticket, I am accessing the same application. Another person also wanted to access the same application and book one ticket. There cannot be a booking of ticket simultaneously because the other person is using the application. This person has to wait for booking the application, so he just need to wait for some time because he's using it, like it takes 10 minutes, so he need to wait for that and book his ticket for application. This is the issue of concurrency. Have you ever wondered that Amazon handles these concurrency issues? Because I can book a ticket, like I can order something and you can order something. If there is no stock, then it will be displayed, so it is issued by Amazon. But how? Then the solution is, in 1970s, DBMS came into picture. What is DBMS? DBMS is a simple software that stores, manages data efficiently. It acts like a digital library. You can tell it what you want and it finds and organizes the data for you. Here the DBMS has solved the main issue. Let's know what is DBMS. Database Management System, which stores and manages data efficiently. It solved the main issues of the flat file system. No more size limits, better security with access control, easier data retrieval, consistency and accuracy. Then there are types of DBMS. First, they have came up with the concept of RDBMS. What is meant by N in the database management system? It refers to the network. Network DBMS got failed. It did not work for the issues and it did not went so far. Then HDBMS came into the picture. Then after, what's the H in this HDBMS is hierarchical database management system. This also got failed, and later on we got RDBMS, which went a huge success. And what is R stands for? It's a relational database management system. So a relational database management system takes things to next level. That means it organizes in data into tables, where each table has rows and columns, just like Excel. For example, if you might have one table for a customer and other table for orders, then the beauty of this is you can connect them using relationships. That's where the relational part means. So there are 12 rules for RDBMS given by EF code. We'll learn more about those 12 rules of RDBMS in detail in coming up videos. But based on those 12 rules, to 10 rules we got to invent RDBMS software. So this is just a concept. By using this, they built a software. So there are 7 softwares: Oracle, SQL Server, DB2, Netezza, MySQL, Teradata, PostgreSQL. So how are you going to give input to these softwares? Is it C++, C or C++? No, it's complicated. Then people wanted easy language to communicate with that. Then SQL language came into the picture. Here we communicate to these softwares with SQL language, but this SQL language and this MySQL software is completely different, where I can say that software is different from language. You understand the difference between language and software, right? By using software, we can find the data, retrieve it, access it, and we can do our retrievals. So this concept was introduced by EF code at IBM in 1970s. So it changed the way the world stores the data forever. And why SQL and RDBMS won? After trying hierarchical and network database models, the RDBMS concept won because it's simple, logical, and scalable. And the magic language to communicate it with the database is SQL, structured query language. With SQL, you can store, retrieve, update, and delete data with basic simple English commands. So that's the reason SQL 1. So when you type, for example, if you type select star from customers, it means selecting all the data from the customers table. Then you're basically saying, hey database, show me all customers. That's how natural SQL is. So a real world application for every major company today, from financing to healthcare, uses database. When you apply for a loan, when you book a Uber ride, when you stream a Netflix show, all that's powered by SQL database. SQL is truly a universal language. A universal language of data. It's the first skill every data analyst, data engineer, and BI developer learns before jumping into advanced tools. So let's summarize what we learned today. Data existed long before the databases, and flat files issues like security, duplication, and performance, and DBMS solved those issues, and RDBMS got introduced. Relationships and structures. We also got to know the difference between RDBMS softwares versus SQL language. And how SQL became the universal language of interacting with data. And that's all for our first episode in this series. In the next video, we'll explore more SQL in detail, its version, setup, and how to start. Keep exploring, keep asking questions, and keep decoding. To all my written viewers of Data Champions, you are doing amazing. If you found this helpful, please give a thumbs up. Share it with your buddies who are starting their data journey. Don't forget to subscribe. This is Tina decoding with you. Until next time, keep your data dreams alive.